the 17th of January 1918. Arras, France, 4,200 meters above the frozen earth. The air at altitude was a living blade. It cut through leather, through wool, through skin. Lieutenant Klaus Müller could feel it even inside his fur-lined cockpit, a cold so profound it made his teeth ache and his fingers stiff around the control stick of his Albatros DV. Below him, the Western Front stretched like a scar across the face of Europe, trench lines etched in mud and blood, artillery craters pocking the landscape like the surface of some dead forsaken moon. But up here, in the thin air, where eagles dared not venture, there was a different kind of war, a war of speed and angle, of nerve and calculation. A war where death arrived not with the thunder of howitzers, but with the stuttering cough of machine guns and the sudden, terrible silence that followed. Müller adjusted his goggles against the wind. His patrol had been routine 3 aircraft sweeping the sector between Arras and Cambrai, hunting for British reconnaissance planes that ventured too far from their lines. They had found nothing. The sky was empty, a pale winter void that swallowed sound and hope in equal measure. He was about to signal his wingmen to turn for home when he saw it. A dark speck against the clouds. Then 2. Then 3. His heart quickened. Allied aircraft. The range was still too great to identify the type, but their formation was tight, professional. Probably scouts. Müller raised his hand, gesturing to his companions, and pushed his stick forward. The Albatros responded instantly, nose dropping, engine howling as gravity pulled them into a hunting dive. The wind became a scream. His goggles vibrated against his face. He checked his twin Spandau machine guns mounted above the engine cowling, their barrels protruding just beyond the arc of his wooden propeller. Everything was in order. Everything was as it should be. Then, the Allied formation turned toward them. Not away. Toward. Müller felt the first cold finger of unease trace down his spine. British scouts typically avoided confrontation when outnumbered, preferring to run for their lines rather than engage. But these aircraft, he could see them more clearly now. Single-seat fighters with American roundels painted bright on their wings were accelerating into an intercept course. And they were doing something he had never seen before. They were firing. Not in short, careful bursts saved for close range. They were firing from 600 meters away, their guns blazing continuously, streams of tracer rounds arcing through the cone like luminous threads weaving some impossible pattern. And the sound, even through the roar of engines and wind, he could hear it, not the intermittent hammering he was accustomed to, but a sustained, mechanical thunder that seemed to come from everywhere at once. The American fighters were closing fast, and they were still firing, and their propeller blades were spinning directly in front of their guns. It was impossible. Müller had been flying since 1916. He had survived. Verdun and the Somme had sent 11 Allied aircraft down in flames, had earned the Iron Cross First Class and the respect of men who did not give respect easily. He knew the limitations of aerial combat as intimately as he knew the lines of his own face. He knew that machine guns mounted to fire forward through a propeller arc required an interrupter gear, a mechanical device synchronized to the engine that prevented bullets from striking the wooden blades as they spun. He knew that such systems were temperamental, prone to malfunction, that they limited rate of fire and required constant maintenance. He knew that every German, British, and French fighter in the sky carried these same limitations like invisible chains, but the Americans were firing as if those chains did not exist. The first tracer rounds snapped past his cockpit, so close he could feel the pressure wake. Müller threw his aircraft into a hard turn, his vision greying at the edges as centrifugal force crushed him into his seat. His wingmen scattered like startled birds. One of the American fighters flashed past him in the opposite direction, and in that fraction of a second, Müller saw it clearly. A Spad 13 painted in olive, drab and brown, its Vickers machine gun mounted on the engine, cowling, firing in a continuous stream that seemed to mock every principle of aerial gunnery he had ever learned. The Americans swept past and began a climbing turn for another pass. Muller tried to position for a shot, but they were faster, more aggressive. One of them came at him head-on, a tactic so reckless it bordered on suicide. Both pilots were firing now, their guns pointed directly at each other across a closing distance that shrank from 400 meters to 300 to 2 in the space of heartbeats. Muller could see the muzzle flashes from the American's weapon, could see the tracer rounds reaching for him like accusing fingers, and still the propeller spun between them. Still the American fired without pause or hesitation. At the last possible moment, both pilots broke. Muller pulled up and left, his albatross shuddering with the strain. The American went right and down, and as they passed within meters of each other, Muller looked directly into the other pilot's cockpit. He saw the leather helmet, the goggles, the white scarf streaming in the wind. He saw the American's hand on the trigger, never releasing, and he saw something else that would haunt him for years to come. He saw certainty. Not the desperate aggression of a cornered animal, not the wild fury of a berserker. The American pilot's movements were controlled, methodical, precise. He flew the way a factory worker might operate a machine with the confidence of a man who trusted absolutely in the tool in his hands. There was no hesitation, no fear of mechanical failure. The American simply pointed his aircraft at the enemy and fired, knowing with a faith that bordered on religious conviction that his bullets would go where he aimed them and that his propeller would not explode into splinters. The engagement lasted less than 3 minutes. When it was over, one of Muller's wingmen was dead, his aircraft spinning toward the earth with black smoke pouring from its engine. The second had fled east with bullet holes stitching a line across his fuselage. Muller himself landed at his airfield with hands that shook so badly he could barely unbuckle his harness. He sat in his cockpit for 5 full minutes, staring at nothing, trying to understand what he had just experienced. The mechanic who helped him down was a veteran named Schmidt, a man who had been maintaining fighters since the beginning of the war. He took one look at Muller's face and said, "You saw them, didn't you? The Americans with the guns that don't stop." Muller could only nod. "They're going to kill us all," Schmidt said quietly. "Every one of us." The technology that Klaus Muller encountered that frozen January morning had a name, though he would not learn it until months later when intelligence reports began circulating through German aviation units. The Americans called it an interrupter gear, but that term was criminally inadequate. What the United States Army Air Service had deployed over the Western Front in late 1917 and early 1918 was not merely an improvement on existing synchronization systems. It was a revolution so complete, so thoroughly engineered, that it rendered every other aerial weapon system in the world instantly obsolete. To understand the magnitude of this advantage requires understanding the problem that had plagued fighter aircraft since the beginning of aerial combat. A machine gun is most effective when it points in the direction the shooter is looking. For an aircraft, this means mounting the gun to fire forward along the longitudinal axis of the fuselage. But the propeller, the very mechanism that generates thrust and allows the aircraft to fly, spins directly in front of the pilot, blocking any forward line of fire. Early solutions were crude. Guns mounted on the upper wing to fire over the propeller arc, or side-mounted weapons that required the pilot to fly at an angle to his target. These configurations were awkward, inaccurate, and dramatically reduced the effective firepower of the aircraft. The German Fokker Eindecker of 1915 had pioneered the first practical interrupter gear, a cam-based mechanical system that used the engine's rotation to momentarily halt the machine gun's firing mechanism whenever a propeller blade passed in front of the barrel. It was brilliant in concept, but limited in execution. The Fokker system reduced the gun's rate of fire by approximately 30% and was prone to timing errors that could destroy a propeller in seconds. British and French systems developed in response were marginally better, but shared the same fundamental limitations. Every power engaged in aerial combat accepted these constraints as inevitable laws of physics, like gravity or drag. American engineers did not accept them. When the United States entered the war in April 1917, its military aviation program was nearly non-existent. The American Air Service possessed fewer than 200 aircraft, most of them obsolete trainers. Not a single American-designed fighter aircraft existed in operational service. The industrial infrastructure for aviation manufacturing was primitive compared to European standards. By every conventional measure, the United States should have spent years catching up to German, British, and French aviation technology. Instead, American industry did what it had done in every field it entered. It ignored tradition and reinvented the problem from first principles. The American interrupter gear that Klaus Müller encountered was not a mechanical system but a hydro-pneumatic one. Developed by a team of engineers from Packard Motor Company and tested at McCook Field in Ohio, it used oil pressure from the engine to drive a precisely calibrated hydraulic trigger mechanism. The system achieved synchronization not through cams and springs but through fluid dynamics, allowing for timing accuracy measured in milliseconds rather than the crude quarter-second intervals of mechanical systems. The result was a machine gun that could fire at nearly its maximum cyclic rate up to 650 rounds per minute for the Vickers gun, while maintaining perfect synchronization with the propeller at any engine speed. But the true genius of the American system lay not in the interrupter gear itself, but in the industrial philosophy that produced it. German and British synchronization mechanisms were crafted by skilled machinists, hand-fitted to each individual aircraft, requiring hours of adjustment and regular maintenance. The American system was designed for mass production. Every component was standardized, interchangeable, manufactured to tolerances measured in thousandths of an inch by precision machinery. A mechanic could remove and replace an entire synchronization unit in under 20 minutes using basic tools. The system required no adjustment, no fine-tuning. It simply worked, with a reliability that bordered on the miraculous. German intelligence officers who examined captured American fighters reported their findings with a mixture of awe and despair. One report, filed in March 1918, stated, "The enemy's fire control system represents not an incremental improvement, but a categorical transformation in aerial weapon effectiveness. Our pilots report that American aircraft fire continuously for periods exceeding 30 seconds without interruption or apparent concern for propeller strike. This sustained fire creates psychological effects disproportionate to the actual increase in hit probability. Our aviators describe a sensation of facing not a single opponent but an entire squadron, as if the enemy possesses an inexhaustible supply of ammunition and an impossible immunity to mechanical failure. The psychological dimension was crucial. Combat in the First World War was a war of nerves as much as machines. Pilots on all sides flew aircraft that were barely controllable, powered by engines that failed without warning, armed with guns that jammed at the worst possible moments. They lived with constant, intimate knowledge of their equipment's fragility. A German pilot approached each engagement with mental calculations running constantly in the background. How many rounds remaining? How long before the gun overheats? Whether the interrupter gear might fail and send bullets through his own propeller. These calculations were survival instincts, hardwired through experience. American pilots operated under different assumptions. Lieutenant Edward Rickenbacker, who would become America's highest-scoring ace of the war, described the experience in his memoir. When you pressed the trigger of a Spad with American guns, you knew, not hoped, but knew that it would fire until you released the pressure or ran out of ammunition. You did not think about whether the synchronizer would fail. You did not plan around potential malfunctions. You simply aimed and fired, with the same confidence a man has when he flips a light switch in his home. The gun was not a temperamental tool but an extension of your will, as reliable as your own hand. This confidence manifested in tactics that seemed suicidal to German pilots. American fighters would hold their fire until ranges under 200 meters, then unleash sustained bursts of 30 or 40 rounds, far longer than any other nation's pilots dared attempt. They would maintain continuous fire through rolling maneuvers, trusting their synchronization systems to function at any attitude or G-force. They would engage in head-on passes, both aircraft firing simultaneously, each pilot betting his life that his gun would not betray him. And the Americans kept winning those bets. By spring of 1918, German fighter units reported a phenomenon they called Amerikanische Feuerüberlegenheit, American fire superiority. It was not that American pilots were more skilled or their aircraft more maneuverable. The French SPAD X-10 that many American squadrons flew was a solid design, but not dramatically superior to the German Fokker D-7. What tilted the balance was the ability to deliver overwhelming firepower at critical moments. A German pilot might get one good burst in a diving attack before having to break off and reset. An American pilot could stay on target, firing continuously, until the enemy was destroyed or fled. The statistics bore this out. American fighter squadrons achieved kill ratios significantly higher than their British or French counterparts flying identical aircraft. The 94th Aero Squadron, commanded by Captain Eddie Rickenbacker, recorded 70 confirmed victories against 18 losses in the final 6 months of the war. The 27th Aero Squadron claimed 41 kills against 9 losses. These numbers were unprecedented for units flying with pilots who had, in many cases, less than 6 months of combat experience. German pilots began to develop specific recognition patterns for American fighters. They looked for certain aggressive approach angles, certain formations that sacrificed defensive positioning for maximum fire concentration. Most tellingly, they listened. Experienced German aviators claimed they could distinguish American fighters by sound alone, not the engine note, which was identical to French SPADs, but the sound of their guns. The continuous hammering was distinctive, unmistakable. It became a warning, a signal to break off engagement if possible. But often, breaking off was not possible. Hauptmann Friedrich Stolz commanded Jasta 43, a fighter squadron stationed near Cambrai in the spring of 1918. He was 27 years old and had been flying since before the Battle of Verdun. He had 31 confirmed victories and a reputation as one of the most analytically minded officers in German aviation. After his squadron encountered American fighters 3 times in a single week, losing 2 aircraft and 4 pilots, he did something unusual for a combat commander. He sat down and wrote a detailed technical analysis. The report, discovered in German military archives in 1956, provides remarkable insight into how German pilots understood and tried to counter the American advantage. The enemy possesses a weapon system that allows sustained fire approximating 4 times the effective duration of our own synchronized guns. This creates a tactical asymmetry that cannot be overcome through superior piloting or courage. In a typical engagement of 30 seconds duration, a German pilot might fire 2 or 3 bursts, totaling 20 to 30 rounds. An American pilot can fire continuously for 15 to 20 seconds, delivering 150 to 200 rounds in the same period. The probability of scoring hits increases not linearly but geometrically with sustained fire, as each tracer allows the pilot to adjust aim in real time. Our tactical doctrine must adapt to this reality. We can no longer afford extended turning fights with American squadrons. Our advantage lies in altitude, in surprise, in diving attacks that allow no time for the enemy to bring his superior firepower to bear. We must strike and escape before the American can establish his aim. Any engagement that extends beyond 15 seconds favors the enemy proportional to its duration. But there is another factor, more difficult to quantify but perhaps more significant. Our pilots report a psychological effect when facing sustained American fire. The human nervous system expects machine gun fire to be intermittent, predictable. We unconsciously time our evasive maneuvers to the rhythm of enemy fire, anticipating the pauses. American guns provide no such rhythm. The fire is constant, relentless. Pilots describe a sensation of being pursued by something mechanical, inhuman. It erodes the focus necessary for precise flying. Men make mistakes. They panic. I have lost more pilots to crashes following American engagements than to American guns. They return to base with damage that should be survivable, but they are shaking too badly to land properly. Their nerves are shattered. This cannot be corrected through discipline or courage. It is a physiological response to a form of combat stress our minds are not prepared to process. Stolz's analysis was prescient. By summer of 1918, German aviation medicine officers were reporting unprecedented rates of psychological breakdown among fighter pilots, particularly those who had engaged American squadrons repeatedly. The symptoms were distinct from the general combat fatigue seen throughout the war. Pilots described intrusive auditory hallucinations, hearing the sound of continuous machine gun fire even in quiet moments on the ground. Some refused to fly if they knew American squadrons were active in their sector. Others flew but became paralyzed with indecision during combat, unable to commit to attacks, breaking off engagements prematurely. The German High Command attempted to address the problem through technical countermeasures. Fokker's chief designer, Reinhold Platz, developed an improved synchronization system that increased fire rate by approximately 15%. It helped marginally, but could not close the fundamental gap. Some squadrons experimented with mounting additional unsynchronized guns on the upper wing, accepting the awkwardness of split-fire control in exchange for increased volume. This proved more psychological comfort than tactical advantage. The wing-mounted guns were difficult to aim and often jammed. The more effective German response was institutional rather than technical. Fighter units were reorganized into larger formations. Jagdgeschwader, or hunting groups, combining multiple squadrons under a single command. These large formations allowed German pilots to achieve numerical superiority in specific sectors, overwhelming American flights through sheer numbers. It was a tacit admission that German aircraft could not meet American fighters on equal terms. The solution was to ensure the terms were never equal. But numerical superiority required resources, and by mid-1918, resources were something the German Empire no longer possessed in abundance. Aircraft production had peaked in 1917 and was declining as raw materials grew scarce. Fuel was rationed. Experienced pilots were being killed faster than they could be replaced. The American Expeditionary Force, by contrast, was growing exponentially. In March 1918, the United States had 7 fighter squadrons in France. By November, there would be 45, with more arriving every week. And every single one of them carried those guns that never stopped firing. The symbolic power of the American synchronization system extended far beyond its tactical effectiveness. For German soldiers, not just pilots but infantry, artillerymen, officers in headquarters far from the front, the guns that fired through propellers became emblematic of American industrial might, of a kind of technological supremacy that seemed almost supernatural in its manifestation. German troops had spent 3 years fighting British and French forces armed with weapons and equipment that, while effective, were comprehensible. A British Lee Enfield rifle was a finely made weapon, but it was still a bolt-action rifle, operating on principles German soldiers understood intimately. A French Renault tank was intimidating but also prone to mechanical failure and vulnerable to specialized anti-tank tactics. These were tools made by humans, and their limitations were human limitations. American equipment felt different. A German infantryman who surrendered to American forces in August 1918 was interviewed by intelligence officers. His testimony, preserved in U.S. Army records, captures this perception. We were told the Americans were amateurs, that they had no experience of modern war, that they would break easily. Then they came at us with their artillery, and the shelling did not stop for 6 hours. 6 hours without pause. We thought our own artillery was terrible, but this was something else. It was industrial, mechanical, like being inside a factory where the machines never rest. And their aircraft. We would see them fighting with German fighters, and we would hear the guns, and the sound was wrong. It was too continuous, too perfect. One of our officers said the Americans had invented a way to fire through their propellers without hitting the blades, that their machines could shoot forever. We did not believe him at first. It seemed like propaganda, like the stories the British told about German soldiers bayoneting babies. But then we saw an American fighter shot down near our position. It crashed in no man's land. That night, some men from our company crawled out to examine it. They came back talking about the gun, about the mechanisms they saw. They said everything was made with precision, that all the parts fit together perfectly, that there were no adjustments, no hand-filing marks. They said it was like the whole aircraft had been made by a single giant machine rather than human hands. We realized then that we were not fighting an army. We were fighting a factory. A factory that could make perfect guns and perfect aircraft and perfect everything, and that the factory was larger than our entire country. How do you defeat a factory? This perception of America, not as a nation but as an industrial force, a machine of continental scale, became deeply embedded in German consciousness during the final year of the war. The synchronized guns were merely the most visible manifestation of something larger and more terrifying. American mass production applied to warfare with a thoroughness that European militaries, for all their experience, had never conceived. Consider the numbers. In 1918, the United States produced 14,000 aircraft engines. Germany, France, and Britain combined produced 16,000. America had been in the war for less than 2 years and had started with virtually no aviation industry at all. Yet by November 1918, American factories were manufacturing Liberty engines, 12-cylinder, 400-horsepower power plants at a rate of 150 per day. Each engine was built from standardized parts, interchangeable with every other Liberty engine in existence. A mechanic could swap cylinders between engines manufactured in different factories months apart, and they would fit perfectly. This interchangeability, this standardization, was alien to European manufacturing philosophy. German aircraft engines were works of craftsmanship, each one slightly unique, requiring skilled mechanics who knew the quirks and characteristics of individual power plants. They were made to precise specifications, but the precision was achieved through human skill rather than machine tolerance. An experienced German mechanic was an artisan, a master of his trade. An American mechanic was a technician who followed manuals and replaced modular components. Neither approach was inherently superior in peacetime. But in war, when production must scale to impossible levels and equipment must be maintained by hastily trained personnel under terrible conditions, the American system possessed overwhelming advantages. A Liberty engine that developed a cracked cylinder head in France could be repaired by a mechanic who had been working on automobiles 6 months earlier. He would unbolt the damaged cylinder, bolt on a new one from supply, and the engine would run perfectly. A German Mercedes D3IE engine with the same problem required a skilled specialist and several hours of careful work to restore to proper function. This philosophy extended to every component of American military equipment. The synchronized gun systems were not better because American engineers were smarter. German engineers were equally brilliant. They were better because they were designed from the start for mass production, for foolproof operation by average users, for repair and replacement rather than adjustment and maintenance. They were designed, in other words, for a democratic army of citizen soldiers rather than a professional military of specialists. And that design philosophy was itself a weapon. By October 1918, the war was entering its final weeks. The German spring offensive had failed. Allied armies were advancing along the entire Western Front. American forces were pouring into France at a rate of 250,000 men per month. The German High Command knew the war was lost, even as the civilian government continued negotiating for an armistice on terms that might preserve some dignity. Klaus Müller was still flying. He had survived the spring and summer, though most of the pilots who had been with him in January were dead or captured. His squadron had been equipped with the new Fokker D-7, which was an excellent aircraft, perhaps the best fighter Germany produced during the war. It was more maneuverable than the American Spads, could climb faster, handled better at altitude. On paper, it restored parity to aerial combat, but paper did not account for the guns. On October 28, Müller's unit engaged an American patrol near the Meuse-Argonne. The Americans were flying Spad XCs from the 27th Aero Squadron, veterans by now with months of combat experience. The engagement began badly for the Germans. Two of Muller's pilots were shot down in the first pass. The Americans had altitude and sun position, and they dove with perfect coordination, each aircraft selecting a target, firing those sustained bursts that had become their signature. Muller managed to evade the initial attack and position himself behind one of the American fighters. He had a perfect shot, 200 meters range, target steady, no deflection. He pressed his triggers. His twin Spandaus hammered for 3 seconds, perhaps 60 rounds total, and he saw hits spark along the American aircraft's fuselage. Then his guns fell silent. Stoppage. He yanked the charging handles, trying to clear the jam, but his target was already maneuvering away, and another American fighter was turning toward him. He dove for the deck, using his Fokker's superior climb rate to escape into a thick cloud layer. He flew for 20 minutes before he was certain he had not been followed, then turned for home. When he landed, his hands were shaking again, just as they had been in January. But this time it was not fear, it was rage. Rage at guns that jammed, at equipment that failed, at a war machine that could no longer provide its soldiers with tools equal to their courage. They found the problem quickly, a fractured firing pin in the left gun, poor metallurgy in the replacement parts. It could be fixed. But how many times had this happened? How many shots had he not taken? How many targets had escaped because his equipment betrayed him at the critical moment? And how many Americans died because their guns failed them? He knew the answer to that. He had been fighting them for 10 months. He had never seen an American break off an attack because of a weapon malfunction. Not once. The armistice came 2 weeks later. Klaus Müller survived the war. He returned to Germany, to a country that felt like a stranger, to a defeat that tasted like ash. He would live until 1963, long enough to see Germany rebuilt, to see his nation become an industrial power once again. But he never forgot those American guns, never forgot the sound they made, that continuous mechanical thunder that seemed to come from everywhere and nowhere at once. In 1958, Müller was interviewed by a German television station producing a documentary series on the First World War. The interviewer asked him what moment from the war stood out most clearly in his memory. Müller thought for a long time before answering. "It was not a battle," he said finally. "It was a sound. The sound of American machine guns firing through their propellers without stopping. We had been told that we Germans were the world's greatest engineers, that our technology was superior, that our industrial might was unmatched. And then I heard those guns, and I realized we had been living in a fantasy. The Americans had not just matched our technology, they had rendered it obsolete without us even understanding what was happening. That was the moment I knew we would lose, not because American pilots were braver or more skilled, but because they had something we did not, something more fundamental than courage or skill. They had absolute faith in their tools. They never had to think about whether their equipment would work. It simply did. And that faith freed them to focus entirely on fighting. We spent the war fighting the Americans and fighting our own machines. They only had to fight us. In the end, that made all the difference. The synchronized gun system that terrorized Klaus Müller and his fellow German pilots was, in the grand scope of military technology, a relatively minor innovation. It did not win the war. American numbers won the war, numbers of men, numbers of tons of supplies, numbers of dollars spent. The synchronized guns were merely a footnote, a technical curiosity that gave American pilots a marginal advantage in a conflict already decided by economics and industrial capacity. But footnotes can be revealing. The American approach to the synchronized gun problem illustrated a philosophy that would define American military power for the next century. The belief that technology could be designed not just to work, but to work reliably for everyone. That complex systems could be engineered for simplicity, that the goal was not to create perfect tools for master craftsmen, but adequate tools that any trained person could use effectively. This was democracy applied to machinery. Not in any political sense, but in the deeper sense that tools should not require genius to operate, that competence should be accessible, that a farm boy from Iowa with 6 months of training should be able to perform at the same level as a Prussian aristocrat with years of experience. The synchronized gun was designed to make expert marksmanship available to average pilots. It succeeded brilliantly. And German pilots, trained in a military culture that valued expertise, specialization, and the cultivation of individual excellence, found themselves fighting an enemy who had mechanized excellence itself. They were artisans facing an assembly line. They could not win that fight, because the fight was never about individual skill. It was about systems, about scale, about an industrial philosophy that could take ordinary people and, through superior tools and training, make them extraordinary. The propeller continued to spin, as it always had, but now bullets passed through its arc without fear, without hesitation, in streams of fire that seemed to mock the very idea of limitation. German pilots saw those streams and understood, perhaps earlier than their generals and politicians, that they were witnessing the future. A future where war would be won not by the finest soldiers, but by the finest systems, not by heroes but by factories, not by men alone, but by men and their perfect machines working in seamless unity. The sound of those guns echoed across the Western Front in the final year of the war. It was a sound of endings and beginnings, an ending of the old way of war, where valor and skill could triumph over material advantage, a beginning of something new, something that would reshape the world in ways even the pilots who heard it could not imagine. And on cold nights, in the years after the armistice, when German veterans gathered to drink and remember, they would sometimes grow quiet and distant. If you asked them what they were thinking about, some would say nothing, would shake their heads and return to the present. But others, if they knew you well enough, might lean close and whisper, "I was remembering the sound of their guns, the guns that never stopped. It was the sound of the future arriving, carried on the wind at 4,000 meters, delivered through propeller blades that impossibly survived. It was the sound of American industry translated into violence. It was the sound of certainty, of machines that worked exactly as designed, of a nation that had looked at war and treated it like any other engineering problem to be solved with precision and mass production. It was, in the end, the sound of inevitable defeat. And once you heard it, you never forgot.